Okay, welcome to our Explore Lakes with New Hampshire Lakes webinar series. Tonight we are going to have a presentation by my good friend Abby Fopiano Thompson on climate impacts on our lakes. We do have some great webinars coming up in the next months. We have microplastics in February, septic systems in March, and lake birds, beautiful but sometimes problematic, in April. That'll have a focus on the Canada goose and management strategies. And just a couple housekeeping things before we get started. This is going to be recorded so we can share it with others after the fact. And we do ask that everyone stay muted and keep your video off for the duration of the presentation. You can submit questions in the chat box. So either at the top or the bottom of your screen, if you're not familiar with how Zoom works, there is a little button for chat. You can type a question in and everyone will be able to see that. Our team at New Hampshire Lakes will do our best to answer those questions during the presentation, but of course we're not the experts, Abby is. So we will do our best to save those for the end and read those to Abby and get to everyone's questions. If we run out of time and we don't get to your question tonight, we will ask that you either email us at New Hampshire Lakes, or if Abby wants to share her email address, we can do that as well. But usually we get to all of them by the end. Tomorrow, you're going to receive an evaluation form from us asking how we did tonight, how the presentation went, if you like the topic. And we also ask that you share your feedback for other presentations, topics you want to hear in the future. We want to give you guys the information you're looking for, so please do fill that out and let us know how it's going. You will also receive an email with links to the webinar recordings. So if you want to share that with your colleagues or friends or family, and also the slides. And we do also have the links to previous recordings and all the registration links for the webinars I just mentioned. So just a little bit about New Hampshire Lakes for anyone who doesn't know who we are. We're the only publicly supported nonprofit organization working for all of New Hampshire's 1,000 lakes. You can support us today at newhampshirelakes.org. We're working to keep our lakes clean and healthy for now and in the future. And we work with partners and promote clean water policies and responsible use and inspire the public to care for our lakes, not for just us, but for all of the future generations. And we have 3 programs where we like to do that. So we have our advocacy program where we are giving our lakes a voice at the State House. We're just gearing up for the 2022 legislative session. If you're interested in participating or helping with that, you can reach out to Michelle Davis. She's our advocacy and policy program manager. We also have our conservation program that runs our very well-known lake host program, where we are inspecting boats to make sure that they aren't bringing invasive species into or out of our lakes. And our somewhat new, although we're going into our 3rd year here with the Lake Smart program, where property owners can take a survey, find out how lake smart they are. We give you instant feedback, letting you know things you can do to make improvements. When you do become lake smart, you get a great sign, hang on your property, show all your neighbors. And then last but not least, our outreach program, which brings you our webinar series that you're tuning into tonight. And very exciting, we're hoping to bring back our popular Lakes Congress in person this year. So keep an eye out and save the date for that. Will be happening at the end of May or beginning of June, I believe it is this year for those dates. And we're your hosts this evening. I'm Erin Mastine. I'm an outreach program coordinator, and Gloria Norcross, she's our conservation program assistant. We'll be manning the chat box as we get started. And without further ado, our expert presenter, Abby Thompson. And at this point, Abby, I will stop sharing my screen and you can take over. Welcome and thank you.
Excellent, thank you, Erin. Give me just a second here as I start to get my screen in order. And close this down. Okay, can we see that, Erin?
Yeah, it looks great.
Full screen? All right, excellent. All right, thank you all for tuning in. I'm going to talk to you today about climate impacts on our lakes. But not just the lakes, really. I'm also going to talk about our wells and groundwater and surface water levels. And the climate I'm going to talk about is really about drought as well as heavy rains. And I'm actually, before I get going, I want to stop my video, I think, right? So that we have good bandwidth here. Okay. All right, so first I'm going to talk about climate a little bit. I'm going to talk about the drought. I'm going to talk about the drought a little bit more than I am about heavy rains, just because we have had quite a few droughts in the past, few years that people can remember. And I want to get into a little bit more detail for everyone about how a drought is determined and, the durations of droughts and, what kind of brings us into them and what brings us out of them. I think that's an important story to tell. Then I'm going to talk more about groundwater, wells, different types of wells, what we see with groundwater fluctuations, and surface water, so both in streams and lakes, and how those fluctuate and what the drivers are, including the climate drivers. And then finally, I kind of want to come back around to what are the impacts here from the drought and heavy rains, and really through some photographs of wells and lake shorelines, and kind of give you a picture as we go along. And as Erin said, please submit any questions that you might have, and I'll gladly answer them towards the end. So first, I really want to talk about low water conditions. So in low water conditions, it's drought, right? We aren't getting enough rain is the first thing that one would think of why we get into a drought. And what does it take to get out of that? So here I have a couple pictures. The first one is a picture of the dam. This is up in northern New Hampshire. This is on the second Connecticut dam. And this picture I took in September of 2020 after we had gone through a summer of pretty low water conditions, as well as a dug well. This is with the cement tiles about 12, 15 feet deep. This is looking right down into the well, and you can actually see the mucky, sandy bottom there with no water in it. So this was definitely what we saw in July into September of 2020. So let's first kind of take a step back and look at the drought occurrence in New Hampshire over time. Up until the mid 2000s, we were using what's called the Palmer Index to dictate when we had a drought. So this graph, it really has each decade since 1900 kind of listed out here by row. And you can see the red where we've had droughts, and the darker red, getting to almost black, is more severe the drought has been. So even though we're in a pretty water-rich area, in general, we definitely experience drought, and we experience it a few times a decade. And that's been pretty common up until, for the last 120 years on record. And we are pretty water rich. I mean, we do get quite a bit of rain, and I'll kind of tell you that I think we've been getting more rain lately. But we don't have a lot of storage. A lot of times we think about the drought in the Midwest or out in California, and they have different types of surface water bodies and reservoirs and different groundwater aquifers that can hold a lot more water than we can. Our geology is such that we have some glacial deposits and sand and gravel deposits, but there's really not a lot of storage in there as compared to other parts in the US. And we also get a lot of our water from our bedrock aquifers, and we can't store a lot of water there either. Water in bedrock flows through fractures, and we don't have really these big caverns, to hold a lot of water. So we really are pretty susceptible to drought, or that, precipitation and the other drought factors are sort of heightened for us, and that's why we see drought. The worst drought that we have on record for not just New Hampshire, but New England really was back in the 60s, 63 to 67. And I wasn't alive at that time. I don't know if anybody in the audience remembers it, but you can actually, if you're really interested, I would say Google 1960s drought in New England, and it's pretty interesting. You'll find some old newspaper articles about how people were reacting and dealing with this multi-year drought. And now we still worry about a potential multi-year drought and what that would mean. And we've had a couple shorter ones in the past 10 years or 20 years. So after 2000, we went to the US Drought Monitor, which started to tell us the story of how drought was occurring in a different way. We were able to sort of visualize this over, spatially over the state. We still had the same type of intensities, from abnormally dry to moderate to severe to extreme and even exceptional drought. But it's depicted to us in a different way, which is much more helpful to make decisions, really. So the five pictures here is really showing you the 5 major droughts that we've had since 2000 and what they looked like when they were at their most severe, or the maximum height of the drought. In 2001 to 2002, 2003, we did have this multi-year drought. It didn't get very severe, but it was really dry for a long period of time. And we reacted to that because that was the first drought that we had seen in about 10 years, of that magnitude. And then even more recently, many people might remember the summer of 2016 was very dry, especially in the seacoast. Got a lot of news coverage. And then of course, in 2020, we were very dry as well. Yet 2021, we went into the summer of 2021 still in drought, but I think we can all, close enough now that we can all still remember the heavy rains in July of 2021, which helped bring us out of that drought. So the different colors here with intensities, I'm going to show you this graph. I'm not going to read it too much, but essentially abnormally dry, that yellow, which we see most frequently, is sort of that drought warning color. We see that as we start getting into a drought and then as we start leaving the drought. And once we actually get into a moderate drought, kind of this lighter orange, then we start to see some damage and some real impacts. And that just increases as we get to severe drought and extreme drought. We've never seen the exceptional drought level in New Hampshire. And I hope we never do. There's a lot that goes into determining when we're in a drought. And this is it's a YouTube video. It's really worth a watch. I originally wanted to show this to you, but it's about 6 minutes long and I have too much to say myself. So I'll let this be, but these slides will be up online later. And I do think it's worth a watch if you want to click through it because it helps describe it pretty well. But there are a lot of factors that go into determining a drought. It is definitely not just how much rain have we had and how much rain do we need. There's a lot of other factors that we look at. We look at stream flows, we look at lake levels, soil moisture. In New England, we do look at snowpack. We look at what groundwater levels are doing. We look at what's happening, other climate factors, what we expect to come, what has happened, how is agriculture affected, what are forest fires doing, how are the fisheries working throughout the time that we're in, however dry it is. So really all of those factors play a role in determining what severity of drought we're in. And DES, New Hampshire's Department of Environmental Services, has a drought management team, which really leads making some decisions on how we react, or really compiling the data and making decisions on how we react. DES talks back to the US Drought Monitor, help draw the map in New Hampshire, giving them kind of real-time, on the ground information as to what we're seeing. And then there's also a state drought management team that meets within a drought, and that's really made up of a large group of stakeholders that have, could have some impact from the drought. So they kind of give all information back to DES. DES shuffles it around, relates back to the drought monitor, and then really, goes back to the public with the messaging of where we are in drought and what to do. So I think it's worth kind of mentioning some of the legal authorities that we have when a drought occurs, because that's always kind of the question. Most people think, we're in a drought. How come my neighbor is watering his lawn? What can we do? He shouldn't be allowed to do that. And it's not always that easy. So in terms of what legal repercussions we really kind of have as a state, or what DES might have and municipalities might have, is that DES they do have the authority to allow emergency use of certain wells for public water supplies, if needed, or interconnections between public water supplies, primarily as a human health impact to make sure everybody has adequate drinking water and safe drinking water. They do have the authority to require dam owners to release water. If they're not state-owned dams, they do have the authority to say you need to release more water from your reservoir or lake and send it downstream. They also, there's on the municipality level, there is a law that's been in place where municipalities can give the authority to ban residential lawn watering or any outdoor water use during a drought. This is both for public water supplies and residential wells. So, you know, if your neighbor's got a really green grass in the middle of the drought, it's really the municipality, if we're at a certain drought severity, does have authority to try to stop them. Now, having authority and then having means to be able to stop them is a different thing. You know, if you have a law, you have to have a way of upholding that law and personnel and methods and all of that. And many towns don't really have that in place yet, but it is there. A couple other things too that are questions that come up. There are bulk water haulers that do have registrations or approvals to pull water from surface water bodies. So sometimes, you know, the state will get calls because there's a trucker that's pulled up to the stream pulling water out. And often they can reply and say, well, actually, they have the approval to do that. But I mean, there are also other people that pull up and try to pull out water when maybe they shouldn't be. But there is some approval for that. You can't mix surface water and groundwater. So, you know, we get calls, or I've talked to people who have wells near a stream and they want to put a pump in the stream and pump it into their well so then they can pump it into the house. They have water, and that's illegal. You can't do that. And then lastly, I just wanted to mention that really it's FEMA or the Department of Agriculture that provides any or declares any drought disaster at any time. So for actual federal funding for a drought, it's pretty rare that that really happens. It has to be pretty severe, and it's really agriculture that drives that. I just think that's worth mentioning as to, we all kind of can think about natural disasters, right? Floods, tornadoes, hurricanes, and how it's declared a national disaster, and then there's funding to help mitigate. And that usually doesn't happen, or it takes a lot to have that happen for a drought. So I want to go back to showing you the occurrence of drought over the last 20 years in this graph. And we kind of saw the pictures of New Hampshire as we see these major droughts occur. But the main thing I want to show you is that we do have this abnormally dry conditions happen fairly frequently, you know, every year or so. But the more severe droughts, we see this longer duration. I used to see a pretty long duration of the drought coming in and the drought going out. And in the past 10 years, we see this moderate drought occur more frequently, and it happens pretty quickly. So part of my kind of points tonight is that we do sort of have these droughts that are happening faster. You know, they're not as long and spread out as we are used to seeing. And we are starting to see more extreme or severe and extreme droughts occur more frequently. Because we're getting warmer. Our summers are definitely getting warmer. We're up about 2 degrees in the last 50 years. And we're having more hot days. So we are water rich. We got a lot of water on the ground. We got a lot of trees. I mean, the hotter days, we put more water in the atmosphere. And it doesn't always come back down in the way we would think, simply. But these warmer days and these hotter days really increase the drought intensities that we're going to see. And it actually starts to bring up this idea of a flash drought, kind of like I just mentioned. We get severe quick, and then it dies off quick. And that can be pretty detrimental. I mean, if we have these sort of flash droughts, or we get to a increasing in drought over 2 weeks or 3 weeks very quickly in, say, May or June, right at the beginning of the growing season, that can have a major impact on how those crops, thrive throughout the whole summer. Or if all of a sudden we have these kind of flash droughts right in August and into September at the end of the growing season, or recreation season, then that can also have major impacts, both economically for the state. This flash drought is a newer concept. I mean, 10 years ago, nobody said that. Nobody said flash drought, But now it's starting to be common terminology that people are starting to use throughout the country, really. And it might start to get pretty common for us here in New England. So we'll see. But essentially the flash drought, I mean, it's, changing 2 categories of intensity over 2 weeks for 2 weeks. So it's still long term in the sense of, natural disasters. It's not happening flash floods in 3 days, but it's happening much faster than we're used to seeing. So our reaction to it is going to be different and the impacts are going to be different. So a little bit more about climate, some things you kind of already know, I'm sure, but we do have a warming trend happening, and depending on how things go over the next 50 years, depends on how warm we're going to get. But again, these warmer temperatures are really going to affect how, that water stays in the atmosphere and how this precipitation is going to range over time. And this precipitation ranging over time, we have seen more precipitation in the past 20 years on average annually than we have in the past 100 years, 120 years. It's funny to say that because I also say we've had more droughts, in the past 20 years, and more severe droughts in the past 10 years. So it's all sort of related that the patterns are definitely changing now than what we've really seen over the 120 years of record. There's a pretty good website, the State Summaries, NCICS, that has a lot of these graphs and information on, and the link is active in the slides that we put up online. So I urge you to click through and look at those too. And then the high water conditions. So now we've kind of talked about drought, but now with the high water conditions, I go back to July of 2021. I mean, the wettest month on record. Usually we get 3.5 inches, and we had over 15 inches in some places. Now this, aside from being a lot of rain, it was actually really great because it was provided to us over a long period of time. When we're in a drought, we don't want a big 3-inch storm coming through in 12 hours. That doesn't replenish us. That runs off. That runs off and brings a lot of stuff into our lakes, into the streams, and it flows away. It doesn't really recharge the aquifers and sit and stay in our surface water bodies like we want. We really want many, many days of rain. So honestly, after 2020 and early 2021, July was what we wanted and needed. It was just hard because it was right in the middle of the summer and really impacted recreation and the economy because of those impacts to recreation and, crops and other things as well. This other graph here is showing us how we've had an increase in extreme precipitation events over the past 10, 20 years as well. Greater than 2 inches of rain in a shorter period of time. So we're definitely seeing the changes on both sides of high water conditions and low water conditions. So that's kind of it with the basics on the climate. And now I want to talk about groundwater and wells and surface waters. So I'm going to go through types of wells and then how we look at water level changes, both in ground and surface water. So groundwater flows to well. I'm actually more of a hydrologist by trade. I like wells. I like groundwater. So I tend to always want to educate people about wells and how they work. But in New Hampshire, we have essentially 2 kind of main types of wells, or 2 main aquifers that we pull water from. So the first is the sand and gravel that overlies any bedrock that is, or the bedrock out there. We have dug wells, which are typically 12, 15 feet, but can be up to 20, 25 feet. These wells are installed with an excavator. So, you can really only get an excavator 22, 25 feet deep. But some of these, this was the original type well. Some say, they were stone lined, some guy was in there digging it out. By design, water enters these wells from the bottom. Okay, it's just an open bottom sitting on top of the gravel or whatever's there, and water comes in that way. We also have point wells, which are typically installed by hand with a hammer down in with the screen already on it. Water enters through the screen here at whatever depth you get. Most point wells, because they're usually 2-inch pipe, 1-inch pipe installed by hand, are only going to be 20 feet deep or so, or less. Then we have gravel wells, which are deeper and installed in the sand and gravel material. So typically a gravel well isn't going to be installed unless you have 30, 40, 50, 100, 200 feet of this sand and gravel to pull from. And water enters again through the bottom through a screen. Now, away from the sand and gravel aquifer, we have our bedrock aquifers. And a bedrock well, which is predominantly what most private homes and even public water systems run off of, at least small public water systems. The 6-inch steel, or might even be plastic pipe that you see sitting on the ground outside your home if you're on a private well, that only goes so deep into the ground. It goes about 20 to 10 or 10 to 20 feet into bedrock, into competent bedrock. And below that, it's just an open hole. And water flows through the rock in fractures or veins or cracks and enters into the well. And then there's a pump and then you pull it out. So these different types of wells are going to react differently when we have these high water or low water conditions. Essentially, the sand and gravel reacts pretty quickly because water is directly hitting the ground and infiltrating down into that aquifer. Bedrock aquifers, it's a little different because it's not necessarily fed directly from above. These fractures can be pretty widespread in different directions, different angles. It's very difficult to predict where the water is actually coming from that gets into your bedrock well. So these schematics give you a picture of kind of what happens when groundwater levels drop. And this first one is looking at it when we have this, quite a bit of sand and gravel above bedrock. And we can see under normal water level conditions, our groundwaters, the aquifer is pretty full. The water level is right up high in the dug well and the gravel well and the bedrock well here. This is sort of the static water level. I hope you can see my arrow, but here's a static water level in the bedrock. And that's being fed from below here, not from the water up in this aquifer. As that water level drops, well, we can see what happens. This dug well might go dry because the water level is simply below it. And the gravel well doesn't have as much water, available water in there to pump out. And we start to see some bedrock fractures go dry because this water is just depleting out. Now, whether it's because it's being pumped out, it's moving along to fill other aquifers, kind of move, groundwater does move and flow, essentially down toward the northeast towards the ocean. So these do naturally deplete, and we do see natural fluctuations in groundwater throughout the year. Another quick picture here. This is now just essentially the same thing, but we have much less sand and gravel in this depiction. And this is more typical in New Hampshire. In many more places, we really have bedrock pretty close to the surface or materials on top of that bedrock that you just can't put a well in and get water out of. And in these cases, these bedrock wells, they get impacted a little bit more severely when we have low water conditions because these fractures are being fed from a pretty thin lens of water here. So you might find bedrock water levels drop even more. So here's just a real example of what we look at when we're looking at water levels in a well. And if you see this bedrock well with a water level here, this is the static level. Let's say it's not pumping, but as this well pumps, the water level is going to come up and down. And then as we get into high water or low water conditions or just natural fluctuations throughout the year, we're going to see that fluctuate too. So these three lines are three different types of wells. This is actually done, this is a public water supply area, and actually Epping Well and Pump Company does operations of public water supplies, and this is some information they've gathered. But essentially we can see water levels change over time. And as hydrologists, we look at this to try to figure out the health of the aquifer, the health of the wells. The New Hampshire Geological Survey collects data from a number of wells, about 30 wells throughout the state. And they've been doing so for quite a few years. The oldest record is back to 1944. So they use this data as part of really understanding the groundwater in New Hampshire, but also they use it to relay back to the Drought Monitor to help depict where we are and aren't in drought. So here's an example from September of 2020 when we were in pretty severe drought, and you can see the severity here over the state. And here are all the wells, and wherever they're red, the water level was low. And there's a lot of numbers in this table here. I guess really I just want you to see how red it is, that the water levels were low. And there's this departure from average column. And you can see here, negative, meaning lower. And to some, it might not seem like a lot, 1 feet, 2 feet, 4 feet. But in groundwater, that can be quite a bit and can be enough. Now let's go to September 2021, a year later, after all these July rains. And blue means good. Blue is a good color. Water levels are much higher. And this departure from average, I mean, now we're quite a bit higher. We're in bedrock wells, we're maybe 6 feet, 5, 6 feet. And in these sand and gravel or overburden wells, a couple feet here. And we were still in a drought up in the North Country in September 2021. So we do still see lower water levels up there. I just kind of wanted to show you this to understand that there's a lot of data that gets collected here and gets reported back and goes into the whole algorithm of trying to understand, what conditions we're in. So I just want to talk quickly about wells and how in a drought, we seem to be gaining a little bit of resiliency here to droughts as they occur. Because every time they occur, we start replacing wells or deepening wells or hydrofracking wells, trying to make sure that those wells will be more resilient and still provide water in times of drought. So here we just have a number of wells installed throughout each year. And these red clips are when we have drought years. So you can pretty much just see more wells are being installed when we have a drought, which helps give us some resiliency here. Here's another way of showing it where we just see these spikes over this August, September, October, when we usually have the highest severity of the drought in any given year. Each year that we've had a drought, we've had a lot more wells installed. So that's helpful. And typically what we see happening is dug wells, those wells that are first to go dry, are the ones that need to be replaced. So they're replaced with a deeper gravel well or a bedrock well. And over time, now as we have the same severity in the same area where wells have already been replaced, we don't need to replace them as much anymore. In 2020, the big issue there was that the drought was most severe in the North Country, or more severe in the North Country that they've ever seen. And there are a lot of dug wells up in the North Country. So there were a lot of people that were out of water and were really struggling to survive for a while there. But now, having gone through it, they might be a little bit more resilient when it happens next time. So let's get to surface waters here. I'm going to kind of focus surface waters a little on the 2016 drought and then the most recent 2021 drought. But here is some data from the Oyster River down on the seacoast. And essentially what these graphs are showing you is kind of a max high, average highs in purple, average lows in green, and then the normal in the orange. And then the black line is the actual stream flows that we saw for this period of record, being 2016. So in 2016, it was pretty clear as we came into the spring that we did not have much snowpack and we didn't have much spring rains, and we were getting into a period where we were probably going to see a drought. And we saw that with the stream flows. Once we got into the fall, we did get some rains. You can see these spikes here in the stream flow is really representative of a rain event that came through. And once we had some more rain, more continuous rain events into the fall, then those stream flows started to increase and get back to normal. So this was really a 1-year drought event. And then I just really kind of wanted to show you stream flows in terms of the precipitation events, where that one event isn't really getting us out of drought. We need the sustained rains. So here's the 2 years of record from 2020 to 2021. We might have had some good rains in 2020, but it was not strong enough to really get us out of any real drought condition. It wasn't until we had the sustained rain in 2021 of July and even more into August and September that brought those stream water levels way up. And here's another graph that the DES put together as part of the drought monitoring in 2020. It's kind of a confusing graph, but essentially what it's trying to tell us is that when we look at about 37 different stream gauges for the state, and we plot those kind of on a median for the month, we can definitely see we're in these times of drought, we have pretty low stream flow, less than the 3 percentile of stream flows throughout the state. So, I mean, obviously, like you would think, what we have in our streams and our lakes and our groundwater levels are all helping to dictate when we are in a drought or not. But it's also kind of interesting to note that we do hit these levels every now and then, even if we're not in a real drought. So let's talk about lakes a little bit more here. Check my time. So I think we're all fairly familiar with surface water fluctuations in lakes and how it works, kind of a budget where you have water flowing in and water flowing out. You have evaporation, precipitation. You might have some, underwater springs feeding water in. You might have some leakage from that lake down to the groundwater, or under high water conditions, the groundwater can feed the lake. So there's a lot of different factors that help dictate what the lake level is going to be. And it's not necessarily just the rain or no rain that we're getting. And dams. I mean, dams are really kind of a big controller of many of our lakes. And dams are used, I mean, we all kind of understand dams, but during different water conditions, low water or high water, I mean, dams are used to help hold back water primarily, so that we don't have flooding downstream. That's kind of one of the main reasons for them. And then the reservoir of water to release, to let go downstream. So, I mean, people aren't just using the water downstream from withdrawing it for use, but others are actually putting water back in the streams, treated wastewater. And there needs to be a certain amount of flow in that stream in order to put treated wastewater back in it so that it mixes and blends in a certain ratio. So there's a lot of factors to how we operate the dams, and that kind of takes more precedence over what we see in fluctuating lake levels than just how much precipitation we have or haven't gotten. So I like to look at Lake Winnipesaukee, our biggest lake, where we have the most thorough data on, and I live right on it, so that makes me more interested in it. But DES does control the dam in Lake Winnipesaukee, and they keep all those records. So here's 2016, and the bottom part of this graph shows you the precipitation that we got over the year. This pink line shows the discharge that they let out of the dam throughout the year. And then I guess I really just want to draw your attention mainly to the red line on the top, which is the lake level throughout the year. And this is 2016. The blue is kind of this average that we want to see. And we were pretty high until we got into May or June, and then started to have a drought occur. Now, the lake level, it wasn't nearly as impacted, not as close to that low as we may have seen in the streams, right? But it did get pretty low as we got into the end of the year, as they had to continue to release water. Then we did have some pretty low conditions. And I don't know if anybody else is up or was up in this area in 2016 or even 20, as I'll show you in the next graphs. But the lake level has been pretty low in some of these years, lower than I've seen it or remember seeing it in 30 or so years. So now I've kind of put together the 2020 and 2021 similar to the stream flow. And we can get a lot from this from this graph, but really in lieu of time, I kind of just wanted to bring you again to the single rain events versus the long-term multi-rain events and how that affects the lake levels. And in this case, how it might affect how much water they have to release from the dam for this lake as we get all those rains. All right, so now I'm going to kind of bring you through this impacts of climate through some pictures. I'm much better just talking rather than reading words. So I figured pictures is what I'll show you. So we also already looked at this picture of the dam, but I mean, really these dams are designed to allow water to flow through no matter how low it gets. So that's good, but they are also designed to hold back a certain amount of water as the water rises. So it's very interesting. I think it's fun when I know that people are gonna release water from certain dams. And if they're state owned, the state puts out that information of when they're going to do that. And it's kind of interesting to be there when they do it, and especially if it's going to get really low, to see the, you know, the lake bed when you normally wouldn't. So when we're in a low water condition in terms of groundwater levels, we really need to replace wells. I do have this little picture here. So this is a pretty common sight in drought years, and we have a really strong water well industry, but they're not very big. So in the summer of 2016, when people were going dry in August and trying to get a new well, they were on at least a 10-week wait list for that. And in 2020, people were waiting 6 months before they could get a well installed to get water back, which was put a pretty big hardship on a lot of people. People were sharing, neighbors were sharing water, or some people had tanks delivered to their house, you know, 1,000-gallon tanks that they would fill up and ration out. And a lot of people kind of just don't even say anything about how much water they don't have, and they just live off gallon jugs for as long as they can. But replacing wells and deepening wells is expensive. So, I mean, I always urge people, if they've had some experience with low water levels in the past, and a drought's coming, that they start really at least planning and get themselves on a list with a driller to react to them if needed. And then, you know, these low water, high water conditions have larger swings in surface water levels over a short period of time. Again, it's that short period of time that's kind of changing here. So we tend to have more shoreline erosion when that's the case, which impacts vegetation, especially right along that shoreline. Different runoff patterns then going into the lakes, into the streams. Warmer lake temperatures, because you don't have as much mixing, you don't have as much water coming in. So you end up with warmer lake temperatures, which affect the aquatic species, maybe more algal blooms, more widespread blooms. They last longer, harder to get rid of, die off. All of these things kind of play a role here. In this particular picture, we have very low water conditions here. This was at the end of 2020 in September. And we can see, you know, the normal water level is a couple feet higher, but we really have now this erosion down below of these rocks. And it's not just that lower water level is going to make rocks fall out. That's not what's happening, but we still have, you know, recreation on some of these lakes. We still have storms. So now we have these, you know, heavy winds and boat waves that are, you know, banging against these shorelines and causing greater erosion. And as we get through these low water conditions, then we also have more of the recreational impacts where people can't get to boat ramps or boat, you know, the water level is so low and the boat lamps and the lifts that they can't get their boats in or out. Speed limits are enforced, at least on the big lakes in some cases. So there's some real kind of obviously environmental impacts, but also economic impacts with recreation use. Another thing I kind of want to mention here is ice damage. We don't normally think about droughts, or we don't in the winter, right? But they occur and they happen. And more so, we see these different fluctuations in temperature throughout the winter, where we might have ice form, but then we have these thaws, like a January thaw, and the ice breaks up, and then we have these windstorms, and the ice pushes along and buckles and hits the shoreline and causes real damage to any structures that are along the shoreline, or again, eroding the shoreline more than it would. That later ice in, earlier ice out with these thaws in between can cause real problems. And I think we might see this more frequently, you know, as we have these temperature fluctuations throughout the winter. I mean, it used to be that, at least on Winnebago, I remember the white Christmas that lasted till March, and we could go out and snowshoe and snowmobile on the lake all the time, at least for at least 2 or 3 months out of the year. And that window has kind of come down to about 6 or 8 weeks, really. So that has a big impact. And then we have these extreme weather events. Here's another video for you. So this was Hurricane Isaias that came in August 2020. I mean, by the time it was supposed to be a hurricane as it came up through New Hampshire, and of course, in the last couple of days, it died down to just a tropical storm. But there was a lot of rain and pretty heavy winds that came through. So on a big lake like Winnebago, which I'm showing you, there's some damage there. And that video actually is where it was a little protected from the winds. They were kind of coming from the other direction. And there were, in this particular case, that I have family property over here, and there was a lot of boats that were swamped and docks that were ruined, and a lot of damage there. And this damage, I mean, really, these waves coming up to the shoreline can really cause a lot of erosion, especially if we're at that time in August when the water level is already low. That can cause, much more impacts than we're really used to or would expect. And then, of course, heavy winds can take down a lot of trees and other vegetation along the shoreline, sorry. So what have we learned? What should we expect? We got a lot more frequent droughts. Perhaps they're going to be flash droughts as we go. This warming air temperature, more hotter days, more extreme precipitation events, but even just more precipitation overall. You usually have about 44.5 inches, but we've had more of that in recent years. So, what is average now? Groundwater levels fluctuate depending on the type of wells you have, and lake levels are going to fluctuate based on many factors, not just precipitation. But that precipitation is really, a big driver here, obviously, to how wells are going to react going dry. You end up with more water conservation measures, maybe more interconnections between water systems, private wells. We're going to have changes in water quality for surface water bodies just because of those greater fluctuations and the shorter timelines that we have, and erosion to the shoreline. So I think all these things really kind of play a role here in the impacts that we see with this, range in climate of high water and low water conditions. But I don't think it's all bad news, even though I might sound like that. It's just more about understanding how this might play a role and impact us, and what we're going to do about it. So with that, I kind of want to leave you with happy thoughts of rainbows over our lakes. And that's it. So thank you very much.
Thank you, Abby. That was a great presentation. I certainly learned some things. Now I will open up the chat box. If anyone has any questions, now would be a great time to type those in. Although I will say that you did a very thorough job of explaining all of this to us. So possibly nobody has any questions at this point. I'm not getting anything here on my end. So if there was anything else that maybe you didn't touch on that you sort of went over quickly for time, you're welcome to say a few more words. And if not, we can just wrap up a little bit early this evening.
Yeah. Makes me want to show you that drought video, but I'll spare you from that. I think maybe you should, I do want to stress that you go in and watch that video though on YouTube at some point. But no, I think I've said it all. Sorry if I talked a little too fast. I did try to get a lot of information out to you. Most of the information I had there, I got some links on the slide, so you can go sort of read some of those articles and look at them yourself. I am invested in this. I am interested in it. So here's my email, and it'll be on the New Hampshire Lakes page tomorrow or later tonight. But if anybody ever has any questions or sees anything crazy, I'm always interested in good pictures. So keep me informed. And thank you, Erin, very much. It was good to be here.
Yeah, absolutely. Yes, like Abby said, this will be up probably later this evening, and it will be on our YouTube channel and on our website. So anytime you want to go back and reference the slides and watch the links to the videos that Abby's provided, certainly go ahead and do that. And once again, Abby, thank you so much. What a great presentation. And I hope everybody has a great evening.
Yep, thank you. Good evening.
Bye.